Welcome to Chatterjee Academy. So today's session is for Icse class 9, right? So for Icse class 9, as you have know that just we are doing the revision classes, and I'll just give a short session on revision of class 9 ICSE. Part of that, so there is a chapter called pressure, right? So pressure is the force by area or thrust by area, right? If I zoom it out over here, let me show you. Yes, so here pressure is the force by area. Fine. So force means here the thrust. So thrust means what? So what is thrust? So thrust means a force acting on surface vertical, right? So vertical force. Like if something is there. So let me take in weight here. Let's say this having this weight acting downwards, vertically downward. So this object is giving a force on the surface. So force acting on a surface on vertical direction. Maybe it's a downward, maybe upward, right? So force acting vertically on the surface, perpendicular forces. So this is called thrust. Similarly, a liquid column, whenever there is an water bottle is here. So the liquid column, let me take in one more example, right? Where I'll show you the liquid column. So let's say this is a liquid column. So this is having a weight and this will act vertically downwards, right? So this water having a weight and it will act vertically downward on this surface. So pressure means thrust by area. So pressure is acting on this surface, Now this pressure is varied, like this area dependent. Pressure is this area dependent. So more the area will be, so area and pressure is inversely proportional. If area is more, the pressure will be reduced. If area is less, let's say I am taking like this, so area reduced means pressure will be increasing. So if I am reducing the area, the pressure is increasing. That's why whenever we are having the sharp edge, the knife, so the pressure is increasing because pressure means force by area or thrust by area, right? Now this is about the formula. Pressure is equal to force by area. Now what is the units of pressure? Pressure unit is Newton per meter square, right? Newton per meter square. So our 1 Pascal is 1 Newton per meter square. 1 Pascal is 1 Newton per meter square, right? And Cbse unit dyne per centimeter square. Okay, so these are the things you have to remember, or it's a day-to-day activity, right? So thrust is an vector quantity and pressure is an pressure is the thrust per unit area of the surface. It's a scalar quantity, right? So let's go to the other slide of pressure. Okay, now how does this pressure generated? So this is the derivation of that for the pressure, which we are starting from class 8. If you see here, let me highlight here this part. So what we can see that pressure is acting in all directions. If you see here, pressure is acting in all directions, both upward and down. Let's say anywhere, pressure is acting in all directions, vertically downward, vertically upward, lateral, sidewise, everywhere. For any point, pressure is acting like a star. Okay, so this pressure is also having a component on upthrust. That's why whenever we are having an object, it's getting a net upward force. Okay, so this is the liquid pressure formula. So weight of that liquid is H rho g and pressure means thrust by area means H rho g. From here we are getting, so actual formula is thrust by area. From there we are deriving the H rho g, right? So liquid pressure increase with the liquid column. That's why if it is a liquid, so the pressure is here will be less. The more will go to the deeper, the pressure will be increased. So pressure depend on this liquid column height. That's why at the bottom of a dam we are giving the the heavy width because of the to manage the pressures, right? So this is about the pressure, and now what is the upthrust? So cause of upthrust is the one of the component of the pressure, that is the upward pressure. So that's why we are getting the upthrust. Now next is the Archimedes law, right? So what Archimedes told? So Archimedes told that that pressure whenever there is an object, if we are having an keeping an object here, so this object inside the liquid will have two forces. One is the downward force, other one is the upward force. So if I'm taking this liquid always giving an upthrust, like upthrust force, that's called force of buoyancy, FB. This force of buoyancy acting always upward, and whenever the object is trying to float inside this water, right, so it's having a weight downward and upward is the FB. With these two forces, the fighting going on. So that's called law of flotation. So law of flotation, what happened? There is two force, downward is the weight of the object, upward is the upthrust force. With these two forces, what happened that if object has to float, the upward force should be equal or greater than the downward force. So weight of the objects will be equal to the upward upthrust, or weight should be less than the upward force, then only object will float. If the weight is greater than the upthrust force, what happened, or force of buoyancy is lesser than the weight of the object, it will sink, right? So now in class 9 you will be receiving the numerical. So now I will go to the board and I'll show you a solved numerical which I did, for my students to understand. So what is the numerical background is? So numerical is given that there is an wood board, like there is an wood which is having, like, let's say this shape. It is having an height and an area. Area they mention, and they told that this wood is 40 centimeter long. Out of this 40 centimeter, 4 centimeter is out of water. So rest of the part is merged in the water. Now they want to know what is the mass and density of this wood material. What is the mass and density of this wood material, right? That's the questions. Okay, so the question is that there is a wood. For that wood, it is, it is floating in a liquid, and inside the liquid the wood is height is 40 centimeter. Part of that 4 centimeter is out of water, means 36 centimeter inside the water, all in a liquid. Now I have to calculate the density and mass of this wood. So what I am going to do? First of all, it is obeying the law of flotation. So that means Archimedes law of flotation. What is that? That, the weight of this body, the actual weight of this body will be equal to the weight of the displaced liquid, displacement did by this object which is floating. That means whenever the object is floating, it is displacing some liquid or water, right? So that displaced volume having a weight, that will be equal to the actual weight of this object. So that displaced water causing the upthrust force FB, force of buoyancy. FB is equal to V rho G. V is the volume of the displaced water or liquid of this object. How much it is displacing, how much it is inserting in the liquid, that volume into the density of the liquid where it is getting sink or getting floated, and G is the acceleration due to gravity, right? So let's go to the board for that part, so that will help you. Okay, for the same one, I'm just taking my screen over there. Yes, now I hope you can able to focus. Let me zoom it down. Okay, so if you see here, what happened, that 1 minute. Yeah, so this is the liquid of density rho. This is the liquid of density rho. Okay, liquid density rho, and this is the wood block having 40 centimeter height. This is floating in the liquid, and how much it is float? It is partially merged, like 36 centimeter inside the water, 4 centimeter out of water, right? So now the what is the law? Law is that I have to get the upthrust force FB. FB is equal to V rho G. So V is the volume of this wood which is inside the water. So that volume, for that we have calculated the volume here. V of the volume of the wood which is, coming, which causing the displacement, like what is the displaced water or displaced liquid volume, that is the 40 minus 4, 36 into 5. 5 is the area of this part. So we got the total volume, that is, what, 180 cc. So this volume, so now what is FB, force of buoyancy? The volume of the displaced liquid multiplied by density of the liquid into G. Okay, so this part equalize the weight of the wood. Okay, now if you see here, mg, mg is equal to actual mass of the wood and the G. So equalize these two, we are getting the mass of the wood, and from the mass we will get the the density, because we have the mass now, we have the total volume of the wood. Total volume is 40 into 5. So total volume we have the total mass of the wood, we will get the density of the wood. So this way, this kind of things you may receive in your exam paper, annual paper. Now next is the apparent weight. What is the apparent weight? If this wood having a mass whatever mw, when let's say we are measuring in a weighing machine, now measuring is still on. Now you just take this some water and touch it to the wood. So what happened? The wood will get an upthrust force Fb, this upthrust force, and for this its weight reading will be reduced in the instrument. The new weight will be the apparent weight. So apparent weight means what happened, that the reading of the weight getting changed because there is an upthrust force, since it is taken within water. Same happen when you are jumping in a swimming pool. You are getting less weight of you because an upthrust force acting on you. Right, now from here we are getting the relative density. So relative density means the actual density is gets apparently reduced. So that's why the formula of relative density is the actual density divided the density of the liquid or water, which is giving the causing the upthrust. Right? So this is about the, so we covered 3 chapters in class 9. One the pressure, one the condition of floating, and the upthrust and relative velocity. So you can take it as like a cluster. Whenever you are going to revise, take a white page, take these 3 chapters and revise at the same time. Okay. Now one more numerical I am going to explain for you. Right. So that's one. There is a 4-wheeler. If you see my screen here. Okay. So there is a 4-wheeler which was running, and what happened that there is a child, stand over here, and it is the 4-wheeler is trying to save the child. Okay, trying to save the child. So what they have to do? They have to press the brake. They have to press the brake, right, to save the child, and they did that. So what happened? There is a 4-wheeler of weight 400 kg and the weight of the driver is 60 kg. Fine. Now this one is moving with the initial velocity u is equal to 36 kilometer per hour. U is equal to 36 kilometer per hour. Now there is a child in front of the vehicle and it has to save the life, so it stop brake and its final velocity should be 0 before reaching the child. Okay, so it took 4 seconds to stop in front of the child to save the child. Okay, now initial velocity 36 km per hour, final velocity 0, and time interval is 4 seconds to stop the motions. Right. Now from here we can understand this is a retarding motion, means final velocity is decreasing means retardation. So we calculate the retardation. So for that we did the calculation, v is equal to u minus at. So we got the acceleration. Now once we got the acceleration, Newton's second law, force is equal to mass into acceleration. So mass is 460 because mass of the driver and the wheeler total 460 kg. So you will get the acceleration from here. So once you get the acceleration, we will get the force. Force also you receive, right? Force is equal to mass into acceleration. So you have the mass, you have the acceleration. Now if they ask for average, then it will be the f by 2. Right. So this way we will be solving the problem. This is the class 9 standard. Class 9. That's it. So follow my session, and next session I will come up with few more. Okay. Thank you. Thanks for watching. And if you need any 1 month course or any crash course before your exam, maybe class 11, 12, class 10 or 9, just reach us and follow my sessions for lots of free sessions, and only we focus on the conceptualization. Okay. Thanks for watching. Please subscribe. If you like, it will help you. Okay. Thank you. Bye bye.